All right. Can you believe we're in week 5? This is week 5, right? How are we in week 5 already? It feels like we just got here. We just started getting to know each other. This is really crazy. So we're in week 5. As you probably saw, I canceled the
Lab.
yes, sorry. I don't know why the word wouldn't come to me. I canceled the lab. The lab 4, I'm not the biggest fan of lab 4 as it is. So I think I've only assigned it twice, and it was classes that I felt could use that extra practice, but it doesn't teach actually any new skills. It just applies them in a little bit different way. And kind of when I'm teaching the labs, I'm teaching what would be useful in real life outside of here. And lab 4 doesn't really fit that. So sometimes, depending on if I feel the class as a whole needs extra practice, I'll assign it. But week 4 is such a busy week and a heavy week. I kind of base on, do I just feel everybody needs a little break? And if I feel they do, I give you a break and I cancel lab 4. So this week's,
Thank you.
you're welcome. I don't feel like
Yeah,
this
thank
week
you.
is super heavy. I think we're not super heavy on the workload this week. We have what, 6.1, 6.2, and is the hand in homework this week? I can't remember if it's this week or next week. It is this week. Okay. But it's not super, super heavy, especially since there's no test. So that's good. So the math that we're learning this week, it's some of my favorite. I think I say that every week, but I really love that we're starting to actually learn some useful stuff to do with probabilities. And this week, if you grasp the concepts, it's actually fairly useful. In fact, I used the math that we used this week to as evidence that a student was not being honest at high school. I was able to use this math to actually show that the probability that they were telling the truth was about 2.5%. And so I was like, they probably aren't. So it was actually kind of cool. And then the student actually said, okay, you caught me. But it was just kind of funny. So I mean, I use this math in real life, but it's also something that I teach regularly. So I think about it, but I'm hoping that maybe somewhere out there in your real life, this will come back to you and you'll use it. So we're kind of laying the groundwork for some fun calculator functions. We're going to be talking about discrete and continuous random variables. You guys already know discrete and continuous, so I'm going to go over that really quickly. We're going to look at probability distributions for discrete variables, and we're going to be graphing them. Then we're going to look at the means and computing a new mean for a discrete random variable and interpret that. And then we're going to look at the standard deviation. I'm also going to show you a calculator trick that I learned 2 terms ago that'll help you with these types of means and standard deviations. So that's what we're doing today. And it is only 23 slides, and usually we're over 30. So it should probably be a little bit shorter class. We'll see. We'll see how it goes. All right. I'm going to go past that. Okay. So a random variable. It is just basically the numerical measure of the outcome of a probability experiment. We use a capital X. So I could say something like the probability that the value of our random variable is greater than or equal to 12 or something like that. So we will just use it as to say this random variable. So you know that we've been like just writing the words out. Having the letter X there just saves a little bit of space. So we will use probability X is greater than or equal to 12, or probability X equals 5, or whatever. And it just, having a variable instead of a whole bunch of words is a lot easier. All right. So a discrete random variable. So discrete is a finite number of values. We've talked about this before, like number of leaves on a tree, number of children somebody has, number of people who own dogs, or whatever, number of cars people have in their household, things like that. So that's discrete. Next one, continuous. It can take on anything in between, all the values, infinitely many values, like time traveled to work, or how tall somebody is, and things like that. So we've done this before, but I'm just kind of refreshing your memory. A moment. Okay. All right. So let's once again take a look at discrete and continuous. Now, most of you did really well with this piece of the test. So number of light bulbs that burn out in a room, of 10 bulbs in the next year. I'm not going to have a partial light bulb burnout. You're not going to have 1.5 light bulbs burn out. So this is discrete. However, I think the light bulb in my bathroom, you almost could say that's a partial light bulb, because I turn on the light and sometimes it works and sometimes it doesn't. So you could almost say that a half of a light bulb has burned out. So it's probably an electrical issue and not the light bulb, and I should probably get it taken care of. Anyway, number of leaves on a randomly selected oak tree. So it may seem like it's continuous because that number is in thousands and thousands and thousands and thousands, but still it's countable. So this is still discrete because it's still accountable. Length of time between calls to 911. It has to be 3 minutes before it can be 3 minutes and 1 second. So this is continuous. There you go. Okay, moving on. Let's actually, I'm just dying to get to the math because the math is the fun part. Well, for me, the math is the fun part. Okay, so a probability distribution, we've kind of talked about this already a little bit. So it's the possible values of the random variable X and their corresponding probabilities. We did this a little bit when we were doing our probability distribution of, well, I know the hand-in homework, it was like the larcenies, all of those. If you did the week 4 hand-in homework, wasn't that, or was that, yeah, it was, right? The different, yeah. So that's a probability distribution. So these we're going to have numeric outcomes and then probabilities. So it's the same thing. It's just we have numerical outcomes or quantitative outcomes and then their probabilities. And we're going to actually do some math with them. So here's an example right here. So this is the probability distribution for the random variable X, where X represents the number of movies streamed on Netflix each month. So here we go. We have people streaming 0 movies. There's a 6% of people have 0 movies. 58% of the people stream 1 movie, et cetera, et cetera, et cetera. They will all add up to 1 as before. They'll be between 0 and 1, and there will be no negative numbers. So this is a discrete probability distribution. So there's actual numbers here and they're discrete. Those are different outcomes that are possible. Yes, technically you can stream 2.5 movies, but this is just for example. Okay, moving on. So we already had these rules back last week. We talked about them. They all add up to 1 and they're between 0 and 1. This is just basically it's review. You will see we are going to get to some new cool stuff. So probability histogram, our horizontal axis would be the corresponding the random variable. So the number of movies from Netflix would be 0, 1, 2, 3, 4, 5, 6, whatever. And then the vertical axis is the probability. So you may remember a different name to this before. Remember the relative frequency histograms? Yeah, this is the same thing. They just call it a different name because it has the discrete values on the bottom. It's the exact same thing. We just like to call the same thing 20 different names to drive you crazy.
So in any histogram, you want the discrete The discrete on the bottom and the continuous on the.
That's the way we like it. I mean, I know that there's bar graphs and histograms and strange things like that that they do sideways, and those are just fancy. It's not wrong. It's just not the standard way we do things. So, I mean, if you had the bars going like this, I mean, it's not necessarily wrong. It's just not the way we normally do things. Is that what you're talking about?
Just like in the data. So like for me, I did my continuous data in the X and then my discrete data as the Y. So that'll throw it off. I need to flip
Are you
it.
talking about for like when you were doing the linear regression?
No, I'm just kind of starting to collect data for my final project, and I don't have a lot of data, but I'm just seeing what it looks like so far.
Yeah, it doesn't matter. It's if you were doing a histogram, because your histograms, what a histogram does is has like a frequency or a relative frequency or something on it. If you are it's totally different when you're talking about like a dot plot or like a if you're putting like ordered pairs on a graph, it doesn't matter which is which. Yeah.
Okay, thank you.
Yeah. Okay, so we're going to draw a probability histogram of the Netflix data right here. So this is what it would look like. And so when we are using discrete values, we put the values in the center of each of the bars on a histogram. If you were using continuous data, remember we only would label the upper or the lower class limit down there, but this is just what a histogram looks like. I will not be asking you to draw one or create one, but I believe that there probably will be questions regarding this on your homework. So it's good to know kind of what it looks like. So instead of the frequency, you have the probability, which is kind of like a relative frequency. So basically a relative frequency.
And which way did you say that again? If it's in the center, it's the continuous?
No, this is discrete. In the center is discrete.
That's okay. I did it backwards. Okay, thank you.
Sometimes they do things wonky. So these are the general rules of the way we do things. But if you're watching television, I can about guarantee you they're going to do it different because they don't follow rules. The news channels do not follow rules. I could in 20 minutes give you 50 examples of bad statistics. I call it BS, bad statistics on news channels. I have a whole file of them. And it's all across the political spectrum. It doesn't matter. It's CNN, it's Fox News, it's NBC, it's everybody. I have bad statistics from all of them. And I love to just randomly show them, be like, this is a really bad one. I might actually just for fun, post them in the forums just because they're funny. So some of them are really bad and others they're just kind of bad. But some are really bad where you're like, man, they're really trying to deceive me here. Okay, so we're going to, okay, let me see here. Why are we graphing this? Okay, so here, this right here is, this is a basketball player. We asked him to shoot free throws, and this shows the probability of how many free throws he's going to make. We had him shoot 3, and this must be a pretty good basketball player because he made all 3 of them 51% of the time. And I'm going to show you a different way to graph these discrete probability histograms. This graph I'm showing you is not technically a histogram, doesn't really follow all the rules, but it's okay to graph discrete data this way. And it's also really easy if you're doing it by hand. So instead of doing the whole histogram things, just a line with a dot on the top. And this is only for discrete data, only for discrete. So this is technically not a histogram, but it still shows the data pretty well. So for one of my little dots, looks like it fell off the top of the 2. Just ignore that. Just kind of fell off. Can you guys see that? That is kind of like leaning off the edge. Yeah. Like Help me, I'm falling. Yes, I'm crazy. I know it. Okay.
I love it.
Who wants a normal teacher? I mean, really.
Exactly.
Of course.
Exactly.
Yeah. Okay. We're going to do mean. That is when the math gets fun. So okay, before we even do any math, I'm going to explain kind of what this type of mean is. So, like if you go to the casino, like for example, let's say roulette. It's just what I'm thinking of. Every outcome of roulette, there's a lot of them have different probabilities depending on if you're wanting an even number, if you're wanting like 7 or 11, or if you're wanting like red, or you're wanting black or whatever. There's all these different probabilities of them. And what casinos do is they figure out what the probability of landing on each thing is, and that's how they determine the payouts. And based on this, they can make it so that the house wins, but just barely. They can calculate if somebody bets $1, what is the expected payout per every dollar bet. And they will make it so that the expected payout for every dollar bet is less than that dollar. And just barely though, because they need to make it look like you have a chance to win. And the same thing goes with any kind of like card game or even the slots and all of that. These probabilities are calculated. So if I repeated trials over and over and over and over again, there's a certain value that would be expected. So that's what we're going to learn how to calculate. And so here, it's called the mean, but it is also called the expected value. So I'm going to calculate what would be expected. So these probabilities right here, they're actually the Netflix probabilities, but for some reason, the words on it got changed to DVDs. Nobody runs DVDs anymore. So this is the the probability table for number of DVDs people rent from in one visit. So we're going to calculate what the expected value is. If we continued doing trials over and over and over and over again, or watched over time, on average, how many DVDs would we expect each person to rent? The way that we calculate that, this is the formula, but it probably doesn't make any sense. We take each data value. So we're going to show that. Take the data value, multiply it by the probability. So I took 0 times 0.06, a 1 times 0.58. We take each of the data values, multiply it by the probability, and then we add them all together. I know technically we don't have to do this one, but just for consistency, I always do the 0 one, just because to remain consistent. Just take each data value, multiply it by the probability of it happening, and you will get your expected value or your mean. Here's the answer. So it is expected over time that the average number of videos that people rent would be 1.49. We're going to do another one. We're going to math one out by hand where it's not just popping up on the screen. I'll give you a moment if you want to write the math down.
But how can you have a 1.49 movie?
You can't.
Or
This is an
DVD?
average. It's an average. You remember?
Oh,
You remember back in the day? I'm sure you
Okay.
remember. Back in the day when they said that the average American family had 1.5 children. That's kind of the
Right.
same thing. It's just over time it averages to that. So like a casino would do, like, for every dollar that comes in, we would expect to pay out 92 cents. And if you think about over time, they're going to make a ton of money if they're expecting to pay 92 cents. And people are going to feel like they can really win if it's close like that, because they're going to get this sense that it's easy. That's how they also can afford the big payouts when they do hit. We're going to do another one.
Mm.
We're going to do, I guess, first, this is exactly what all these words are, exactly what I just said. So what was I going to say? Oh, this is just the regular mean. Let me see here. Suppose an experiment is repeated n independent times. and then we record the value of the variable, the outcome. If we increase over and over and over and over again, our mean is what we expect to happen. That's what I'm saying. Okay, this is a lot of words. Let's just not even read those. My explanation's better. So here's my trials, like here. So watch. So here's my 1.49. So here's the people visiting. So this person here got one video. And then these people got one video. And so it's showing, I keep doing these trials, I keep doing them, and gradually my average gets closer and closer to that actual. So that's what the law of large numbers means. Like, for example, in my my stats class at the high school, when we're doing our probability unit, every day I have this globe, and the globe is approximately 68% water. So we throw it around and we record where people's right thumb lands, where it lands, whether it lands on water or land. So the first few days that we do it, my numbers are nowhere near 68%. But as we keep doing it every day, and I end up with hundreds and hundreds of trials of throwing this ball around, our percent of water that we get gets closer and closer and closer to that 68%. So as we keep throwing it around, that's the law of large numbers. It's going to approach the actual value. If that makes any sense. That's the law of large numbers. Okay. Okay, this is that word expected value. Because the mean is what we would expect to happen in the long run, we call it expected value. This is the symbol that we use, E of X. So we call it expected value. In your homework, you're going to see the terms expected value. You're going to see mean, and you're going to see E of X. Those are three different ways that you're going to see it in your homework. They are all exactly the same thing. You take your data value, multiply it by the probability, and add them all together. Give you a second to write it down, and we will continue on.
Can you repeat what you just said? You take the data value and you times it by the
Take
mean, and then you
each data value. So my first data value multiplied by its probability of its happening, and then add it to the second data value times the probability of that one happening, plus the third data value multiplied by the probability of that one happening, and on and on and on until you've gotten all of them.
okay, thank you.
Does that make sense? We're going to do another one. Okay. Right.
Now that you said it.
It's okay. I'm cool with that. I'll keep saying it as much as I need to. Okay, so here's an example.
Well, it's more of the spelling it out.
I'm happy to do that. People always think that they annoy me by asking a lot of questions. No, you're not at all. It's what I'm paid to do, and I don't mind it at all. So, term life insurance policy, it pays the beneficiary a certain sum of money upon death of the policyholder. They have premiums, so you pay a premium, and then if you die within that year, then they pay out a certain amount of money. So the life insurance company sells a $250,000 one-year life insurance policy to a 49-year-old woman for $530. So the probability of her surviving the year is this right here. Pretty decent probability of her surviving the year. So we're going to compute the expected value of this policy. So the amount that the insurance company makes if she survives is $530 because she paid that premium. The probability of her surviving is 0.9971. The amount that the insurance makes if she dies is negative 250,000 because they paid that out, but they did still get that 530. So we're going to take that off of there. So 530 minus the 250,000. So this is how much it costs them if she dies. And here's the probability of her dying. So we take both of those outcomes, each of the outcomes, multiply it by the probability, and then add them together. And this is going to give us our answer. So I took 530 times that 0.9971, the negative 249,470 times 0.00209, which is the probability of her passing away. So the insurance company makes $7.50 off her policy. So this isn't just one policy. This is in the long run. So if they sold, let's say, 8,000 of these policies, that's just a number I grabbed, they're probably going to pay out a few of them. There's probably going to be a few of these women that are going to die within that year. So based on that, they're still going to make $750 per policy. So they're still making pretty good money. And they have people who do this for a living. They're called actuaries. You ever heard of actuaries? They work for an insurance company and calculate risk. That's what they do all day long. I considered for a brief moment being an actuary because they start out making really good money. But I don't want to be in a cubicle all day. I would rather, even though I love the math, I would rather be teaching kids, which is weird. But so they all day they calculate risk. They do things like what's the probability of this car seat being safe in this type of a crash and things like that. They do all of that kind of math. They figure out what the premiums are. Questions on this one?
I have a question.
Okay.
What was the math that you did to get the 0.00209?
I just did 1 minus
Oh, gotcha.
99791.
Okay. Thank you.
You're welcome. Any other questions before we move on? Okay. We're gonna do, we already did this one. This is the DVD stuff. We did that one. I believe this is the 1.49, right? Isn't that the same numbers? I believe so. Let me look. Yeah, I don't know what happened there. I think 5, 8, and 2, 2, are they the same values? Let's see. Yep, those are the same ones. We're not gonna do that. We're gonna do the basketball. I would like you to try the basketball on your own. I'm gonna work quietly behind you. I'm gonna let you get started without me. Then after we do this, I'm gonna show you something magical on your calculator, okay? Let's go ahead and calculate it by hand, and then I will show you magical calculator things. I don't even know where my calculator is. Oh, there it is. You should be able to put the entire thing in the calculator at once.
I feel so smart. I got it right.
Yay, good job. How do we do? All right. Would you like to learn fancy calculator things? So I'm a lifelong learner. I'm always wanting to learn new stuff. So I'm always learning new things to do with my calculator. A student taught me this two terms ago. I can't believe I taught it so long without knowing this piece. So to calculate the expected value, so you're going to go into your calculator. I'm going to enter these free throw numbers in here. Go into your edit and go into your L1 and L2. I'm going to clear those out. Okay. So in my L1, I'm going to put my free throw numbers. 0, 1, 2, and 3. Those are the free throw numbers. I'm going to make it a little bit bigger so you can see what I'm doing. And then in my L2, in the L2, put the probability of getting each of those. 0.01, 0.1, 0.38, 0.51. I'll give you all a second to get those numbers in there. So in the L1 column is all of the outcomes. L2 column is the probability of it happening. Okay. Now we're going to go to stat and arrow over to calc, and we're going to use our one variable statistics. So L1 is the same. Your list is L1, but our frequency list is L2. Second, L2. So your outcomes are L1. Your frequency list is L2. It's those probabilities, wherever those are. And then we're going to hit calculate. And look at that. I got 2.39, just like I did calculating it by hand. This is also going to give you, what was that? So this will also give you the standard deviation. I'm going to teach you how to calculate the standard deviation. But there's a math error in my slide that I forgot to fix. So I'm going to show you how to hand calculate it, but we're going to, I would recommend doing this because the standard deviation one takes forever. So I recommend using your one variable statistics for that. But anyway, so 2.39, that mean right there is your expected value. Questions? Super fancy. It seems like something so simple, but it makes me really happy. Okay. Any questions before we move on? All right. So here's the standard
Well,
deviation.
actually, I have a question.
Okay.
I have a question. How are we getting the probable statistics for those?
What do you mean?
You already have those
These are the probabilities.
0 and the, right. How are we getting that?
You'll be given those.
Thank you.
You're given those. Yeah. So
I'm trying to work too hard.
you are. Quit doing that. Take a break sometimes.
Okay.
Feet up. All right.
We'll get them.
Here's the really ugly standard deviation formula. Yeah, I don't like it. I don't know if you like it, but I don't like it. So what you're doing is this is similar to regular standard deviation in a way that you take each value and you subtract it, your expected value from that value. Then you square that. Then you multiply it by the probability of that outcome. Then you do that with the next outcome and the next one, and you're going to add them all together. This is a lot of work. This is why I recommend using your calculator. And we're going to do one, even though there's a math error on it, but you'll kind of get the idea. But we're going to do one by hand. I almost think maybe we should just skip the math error one and just do the basketball one. Yeah, I think we're going to do that. Yep. Y'all all approve? Okay, so let's do that.
Yeah.
We're going to skip all of the math error stuff right here. We're going to go to the basketball. Yep, here we go. I'm going to go back to the basketball. So we're just going to do something completely different. We're going to do the standard deviation. So our mean for our basketball data, what was that? 1.39?
2.39.
2.39? Okay, come on. Okay, 2.39. So I take each value. So I do 0 minus 2.39 and square it, then multiply it by the probability. Plus 1 minus 2.39, square it, multiply it by the probability. You technically could put this entire thing in your calculator at one time. Plus 2 minus 2.39 squared times the probability. Plus 3 minus 2.39 squared multiplied by the probability. And if you only have 4 numbers, it's not that terrible. But if you had 15 numbers, think about how time consuming this would be. So I'm going to just do this on my calculator. Minus 0.3. And feel free to just put all of that in your calculator the way you see it. If you put it in exactly how it's written, it should work just fine with the parentheses and everything. Okay. 2 minus 2.39 squared. Let me make sure, see if I got the same number as the other thing. What? Something went wrong? What the heck? Rude? I'm wondering if my internet went wonky or something.
So we're doing the squared because we're doing the standard deviation variable.
Yes. So
you
you
just-
do, yeah, the data value minus the mean squared times, oh, look at that, times the probability of it happening. Then you add them together. Oh, wait, and then take the square root of your answer. I missed that piece. After you do that, so I have equals. I'm sorry, I forgot that part. Then once you get your answer, this equals 0.4979. Now take the square root of that.
I got 0.7056 and some more further back.
So I think that's what we got in our one variable statistics. Yeah, so our one variable stats is 0.7056. Is this what you said you got? Yeah. See, they remembered to take the square root of it. I can't believe that I missed that part. Sorry about that, guys. Another case of your math teacher is human. You get one of those, at least one of those a week. Questions?
So are we doing, I'm sorry, I got lost. So
Okay.
are we doing, I have the first one written down where we just did the 0, 1, 2, 3, and then we got our answer is 2.39. And then after doing that, then we take the 2.39 and we square it all together.
So it's
Right.
it's like X minus our mean, our mu sub X bar, and then you square that. So this is X1, and then you multiply it by the probability of the first one.
Okay.
So you subtract those two things and you square that value and then multiply that by the probability. And then you do that with the next one. Is that not where you were confused? So this is my first X value minus
Okay.
the mean that we got,
Yeah.
and then I squared that. And then this is the probability of the first one happening right over here.
Oh. Okay.
Did
All right,
that-
that helped. Yeah,
Okay.
I needed the labels, I guess. Thank you.
No, it's okay. It's good. I'm sure somebody else had the same question.
When you enter all that into the calculator, like so you're doing parentheses like for the first set of numbers,
Mhm.
it'd be 0 minus 2.39 parentheses square.
Mhm.
Like sometimes I just get confused on how it needs to be entered because like when I square that
Mhm.
and then I go to do another parenthesis, it's like a tiny parenthesis.
Yeah,
Does
let
that
me
make
show
sense?
you what that looks like. I'll do it on mine. I'm gonna
Okay.
have to go back to the home page apparently and log back in. Give me 1 second here. Maybe not. Maybe, maybe not. Yeah, I don't know what's going on. My calculator app. Darn Texas Instruments. Okay, come on. Come on. Okay. I'll sign in again. I think this thing was like, I think this app is only like $30 for a whole year. So for a math teacher, that's a pretty good deal. Unfortunately, since you can't use online things on tests, it's not super helpful, but there are phone apps, like the Calc 84. Technically, you're not supposed to use those on tests either, but if you were using it, I wouldn't be able to see it anyway. As long as you're not looking up answers.
So I think the problem you were running into is that did you use the caret to add the exponent for your squaring?
I did.
Okay, so
Yeah.
after you use the caret, you have to use the down arrow.
Ah,
back to
okay.
The down
normal.
arrow or the right arrow, either one
Yeah.
of those will get you
Okay.
out of it. So yeah, you were probably stuck in it. So the way that I do it is I do like 0 minus 2.39, and then I just hit the x squared button here. So if you do that, it just squares it.
Okay.
And then times 0.01
Oh yeah, that's way easier.
and plus, yeah, 1 minus, and I just put the whole thing in there, 3.9. So what you did was you hit your caret and then put
Mhm.
it into, so you have to arrow out of it.
Gotcha.
I'm gonna do that. And
Thank
then,
you guys.
sure. So yeah, and then you just put all of these things in here. I'm already here. I'm on a roll. I might as well continue. 2.39. I did not parenthesis that. Rude here. Okay, so 2 minus 2.39 parenthesis 0.38. And obviously, I mean, I use this calculator hours every day, so I'm a little more comfortable with it. But the more you play around with it, the easier it will get. Squared times, I think this is the last one, 0.51 close. So then we get this. Now I'm just going to take the square root of that. And then there we go. So that is exactly what we got using one variable statistics, one var stats. So I highly recommend just use the one var stats. Use the stat, the L1 and the L2. If it's just a few numbers, it's not that big of a deal. Like this was 4. This wasn't too bad. But using the one var stats is just, if you have the calculator, why not use it? All right, bye. See you Thursday. All right. Not you guys. There was comment in the chat. It was in the chat. Sorry. All right.
I was like, wow, that was really quick.
Yeah, I know. No, I'm not out of battery yet. Where am I? No, I still look good. I don't even know where I am on battery. Oh, man, that sucked it down. I'm at 44%. My goodness, good thing we're almost done.
Oh, crap.
Initial panic.
It's okay. We're good. Sorry, I wasn't saying bye to you guys, but somebody in the comments said they were leaving, so I was saying bye to her. Sorry. Okay. So let's talk about the standard deviation. We're going to get through all of this and go away. So basically what the standard deviation, it is just like using the empirical rule. So of our trials as we go, 95% of our values are going to be within 2 standard deviations away, and all of that. It's the same. It's basically the same interpretation. And I believe that they're going to ask you about it, but did I ever tell you guys what variance was? Did I ever tell you about that? Yeah, it's just the squared standard
Yeah.
deviation that I've never used for anything in all of my stats life, but they constantly ask us for it. So it's there. All right, that is actually what is the end of it, because my math error is right in there. And then we weren't going to do the Netflix data because it's too many points. So we're there. You all are, that was it. So I have any questions on camera that would be for the good of the masses. Anybody have any questions for on camera?
Well, are we gonna do 6.2?
No, we're doing that on Thursday. But we actually have 2 days.
I
to-
can't keep it. Hey, I
okay.
can't keep it straight.
It's okay.
Yay.
Yeah, this was a short one because I mean, it just is, there's a few coming up that are basically, they're too short. I mean, they're pretty short for one class, but if I put them both together, it would be too long for two class, or too long to put the two into one class. And so basically we have a few short ones coming up, and then I think we have one more kind of long one, but most of the rest of them are somewhat shorter like this. I mean, we're at basically 6:30. So we've been doing this about an hour, and you know, y'all are awesome. If I would have done this one, it would have taken another 5 minutes and we would have been like, there's math errors on here, and it would have been stressful, and I don't want to stress y'all out. So any more questions?
Yeah, I was following you with your pre-recorded one, and I'm like, what the heck?
See, there were math
So I'm
errors in
glad.
there. That's
Yeah.
one of the ones on my list to re-record pretty soon. It's just, you know, I'm
Okay.
basically the summer is going to be re-recording every single one of those videos over the summer. That's part of my summer work. So it's going to be getting those more up to date, but because of editing and everything, they're time consuming. It takes a long time, a lot of work, but I will get them
I
done.
bet.
All right. Any other questions for the good of the group? I'm going to turn off the recording here in a second. Stop recording.